Hello everyone, welcome to this module on basics of the OCI compute service. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this module, we'll look at the basics of the OCI compute service. So before we get into lots of details, let's look at the various form factors that the service supports today. So the first form factor which we started with when we launched the Oracle Cloud Infrastructure platform in late 2016 is the bare metal shape. And what it means is, as the name implies, you get direct hardware access. So customers get the full bare metal machine. So you get this server. And some people also like to refer this as the single tenant model. So as shown here on the screen, by the bare metal machines, what we mean is you get access to the full server. So right here, you have access to the whole machine. It's a single tenant model. Now, the second flavor is what customers are pretty used to in the cloud model, sort of this shared multi-tenant model where you get virtual machines. So you have a hypervisor where you can run virtual machines with much smaller shapes, much smaller CPU, memory, etc. So as you can see here, in case of Oracle Cloud Infrastructure, we have the bare metal offerings, and then what we do is we put a hypervisor on top of that, and then we divide the bare metal machine into VMs. So it's a typically a multi-tenant model, a shared model. You don't have to worry about the bare metal machine and how it works. I'm just giving you the details. Behind the scene, this all works. You get access to virtual machines, and as you would get with any cloud provider. And the third model, which we launched recently, is called the dedicated VM host or DVH. Now, in a dedicated VM host, you can run your VM instances on dedicated servers that are single tenant and not shared with other customers. So what it means is you get the bare metal machine here, but then on top of that, you can run these virtual machines. And it's a little bit different than the bare metal shape here, because in this case, you get this single tenant model, your bare metal server, and then you also get the ability to run VMs on top of that. In case of bare metal machine here, you have to manage your own hypervisor, you have to install your hypervisor. So definitely you get more flexibility, but then you have to do extra work. Right here with dedicated VM host, we do the extra work for you. You get the single tenant model, and then you can run the specific VM shapes on top of it. Now, the thing to keep in mind is the VM compute instances and the dedicated VM host scenarios. The instances run on the same hardware as a bare metal instance, as we were talking earlier, right? So the commonality here is the bare metal machine. So it leverages the same cloud optimized hardware, firmware, software, networking, etc. So this was a departure from many of the cloud vendors, as we call in Gen 1 versus Gen 2, where we designed this infrastructure to start with bare metal, and then everything was built as a first class citizen on top of it. So what are the use cases for bare metal? Well, anytime you have the highest security requirements or the highest scalability requirement or the performance requirement, you would use bare metal machine. So the first thing is, if you have performance intensive apps, probably you would go with bare metal. For workloads which are not virtualized, and there are still lots of workloads like those, you would of course go to bare metal. Workloads that require specific hypervisor, so you want to install your own hypervisor, do certain things, you would go with a bare metal machine. And then also in cases where you have bring your own licensing, and there are specific examples, you would use a bare metal machine. So these are four predominant use cases, but there are other use cases as well where you would use a bare metal offering. Now, these are the different shapes which are available today in Oracle Cloud Infrastructure. And the best place to check this, because this information keeps changing all the time, is on the documentation site. But you can see some shapes here, starting with standard shapes, which have only block storage. You have dense IO shapes, which have local storage. So you can see big amount of local storage here. You have shapes where we support AMD processors, AMD EPYC processors. Those are denoted by E here. So we have those shapes, we have HPC shapes, we have bunch of GPU shapes, and these are Gen 1 shapes. And again, as I said, we keep launching new families and instances all the time. So the best place to check these are the documentation pages. Now, also note here, we have various OCPUs listed here, right? And we have memory here listed and the network bandwidth. You can see some of these instances have bandwidth going to 50 Gbps, the virtual NICs you can use, etc. Right? One question which comes up all the time is what is an OCPU? In case of Oracle, an OCPU provides CPU capacity equivalent to one physical core of a processor with hyperthreading enabled. So it again, let me repeat, OCPU provides CPU capacity equivalent to one physical core of a processor with hyperthreading enabled. And again, you can go and check this and get more details in the documentation. Now, there are cases for AMD EPYC based instances. The first thing is these are cheaper. So you look here, it's 66% cheaper than the other options out there, predominantly Intel. These are ideal for maximizing price performance. So anytime you are concerned about the price performance, you can go with the EPYC and AMD instances. All our apps are certified to run on AMD, so you can definitely run those. And then there are various scenarios like big data, etc., where you can run the AMD instances, and you can see some numbers here, different scenarios, big data, HPC scenario, computational fluid dynamics, where some of these numbers you can test and see it really is in that price performance realm.